Hi everyone, Nick here, and today we are gonna continue. It's the next day, and I was kind of busy. Not busy, honestly speaking. I was kind of distracted. That's why I didn't record any lecture. But we are going to continue uh, you know, uh, with the foundation of robotics that we were doing. Let me just minimize this thing up. Oh yeah. So we were on page number 32. We have to start over here. Yesterday we did till this particular part. Basically, they were just explaining the older definitions of robotics and what's the difference between the automation and robotics. And they also discussed that in today's era, this book was last updated of 2022. So as of I can say like 2026, the definition of robotics is um, very complex. It's a very complex definition. Okay, let's just start. So autom- uh, anatomical analogies, understanding through replication. Leonardo da Vinci. It is impossible to recapitulate the history of automata without referring to Leonardo da Vinci, some of his works. So he was born in damn 1452. Uh, I don't know how many years back is that, but some of his works of his visionary artist and inventor are also heavily grounded to the age old mythological fascination for the simulation of human beings. In order to implement them, he explored intensively the autonomy and the kinematics of human body. Yes, I'm pretty much aware about that, but as it is well known, his work spanned about all the existing disciplines of his time. Yeah, it's pretty much obvious. I've read some stories about him. It would be different if it would be difficult to say which of his endeavors had the greatest impact on the modern day arts and sciences in an invention and practical treatise. No, how do you pronounce this? Wait, let me see. Google translate.
Treatises.
Treatises. Okay, treatises on mechanism. Treatises on mechanism triggered and propelled the first industrial revolution that came more than 3 centuries later. Some of the pieces and assemblages he managed to manufacture thanks to his unique craftsmanship skills, such as gearheads and pulleys, and now mass produced by complex industrial equipments, but they remain informed by the same design principles. For robotics, sadly, I can't pronounce that word. I'm really sorry. Don't go on my English. I'm not here for studying English. As I already discussed, this book is pretty much full of new English that I've never encountered in my life. The inventions that are most related to the contemporary projects are his mechanical knight on one side and his self-propelled cart, also sometimes referred to as Leonardo's Fiat. Most likely, the first autonomous vehicle on the other cart included a differential drive propulsion system with a programmable steering for travel. Oh my god, what that is? That's crazy. That sounds crazy, huh? So the whole mechanism were originally seen as powered by wound up springs. In 1997, the researchers understood that their real use was not to propel the kite but to regulate its driving mechanism. In 2006, the year in which I was born, a first working replica built at a scale 1:3 was successfully made in fluorescence. All previous attempts have failed because of this misunderstanding. The mechanical knight on the side is a complex machine. It involves the tens of pulleys and gears, which angrily allowed him to sit and stand, move his arm and legs. It was, however, unable to walk. Okay. It was not until 2004 that was the first prototype was implemented. It confirmed the possibility of my bad, possibility of all these actions as well as several other jaw actuation, neck rotation, visor movement. I don't know what that is. That must be related to some sort of degree of freedom, maybe that we encounter in modern robotics. But okay, let's see. Way ahead of his time, while still rooted in the Asian mythology of artificial being, Da Vinci's mechanical knight is connected to the very sense of automation. It stands as a ancestor to several recent humanoids. Okay, that's crazy. And its role in the original design of NASA's Robonaut is said to have to be influential. Oh my god. Oh, NASA's. So let's search for this. Robonaut. So it's basically a. Oh, so it's a basically a human robot, but made for the space, whatever you call it, space exploration. Oh, wait. Holy shit! What that is? That's crazy. Damn. That's crazy. That's crazy. Okay. It is not yet it is not yet possible to account for all of Da Vinci's robotic endeavors, partially because many of them have been lost to history. Oh, sadly. Additionally, as previously started, not all of his surviving designs are complete. In some cases, key components regarding the machinery or the function are missing. In others, as it was the case with his cards. Some of the designs are simply too complex, simply too complex, and yet not fully understood. So so there are indeed some of Leonardo da Vinci's, uh, you know, inventions that we have not fully understood yet, not even in 2026. I mean, that's crazy. He was literally ahead of his time. So I think that's what his humanoid automation is. Okay, okay. The canard, decorator, the writer, the musician, and the drawer. Okay, I might have misspelled that, but again, we're not here to study English. As as can be seen from these first examples, the will to stimulate living beings is very very present in the history of automata and the robots. All of these entities try to replicate the main characteristics of life and to produce deliberatory or not the illusion that may manage to uh, extricated themselves from the nothingness of inert matter. The efforts and the energy invested to generate this illusion implied technologies that are not only systematically accounted for the most advanced. Wait, let me just use for most advanced of its time, but also widely contribute to the evolution of these technologies. Beyond a simple simulation, the automaton was trying to reach the status of an explanative device endowed with descriptive virtues, making it possible to unveil the secrets of life. So it is with Vacanson. I think that's how you spell this. Vacanson.
Vacanson.
Vacanson. Okay, Vacanson. Watkinson's duck, called the digesting duck by its inventor, built at the end of the 17th century. As its inventor says, the whole machine plays without touching it. When you stop it, it forget to tell you that the animal ring dabbles in the water, croaks like the natural duck. Okay, whatever that is. Oh, holy shit! This was built in 1738. That's crazy. I mean, that's really crazy. This picture is a fantasy production published by the Scientific American magazine. Parkinson's drug has been found. Okay, later in the same text, Parkinson mentions the most unexpected feature of his automaton, namely the fact that it digests and deficiates. I think that's how you pronounce. It means basically to poop out things. You know, it's like human. The the simulation of executive function is clever. Very few people would have deli- deliberately implement it for the sake of our illusion. The very idea seems so unusual that it only arises for those who observe it as the consequence of the will to create and entirely that is to perfect like of a living duck, including all its metabolic process. One is at times left with the impression that the inventor surrenders to the illusion that the perfect formation simulation of the basic organs of the life will fool life itself. Wait, what? Wait, what do you mean by that? Uh, it says that the perfect formal simulation of the basic organs of the life will fool itself. What? So it will appear and animate the entity, the small chemical laboratory, wants to be the equivalent of a digestive system by which the food absorbed by the bake would have decomposed into nutritive substances on the side and on the useless substance evacuated through the cloaca on the other. I think I think it's a organ. That's a biological term. I don't have biology as my subject, so I don't, wait. Let me just search for that. Okay, so it basically means the endpoint where from which the animals poop out things. As can be expected, it was later revealed that the Vackinson's duck was a hawks. Wait, hawks. What does that mean? Oh, so it's basically a fake thing. Holy shit. Nonetheless, the fact remained the following Cartesian model, which seems the universe moved by a great watchmaker and living beings as nothing more than sophisticated mechanics, such attempts exemplify the tendency to systematically associate living organisms to the most advanced technologies of the time. Okay. They also mark the beginning of a slow bifurcation by which the evocation and the simulation of the life left the domain of the former analogy to join by a long process that of information follows and transfer. Here again, the separation was initiated by the model of the human being that prevailed at the end of the 17th century, a model that distinguished the body, the material component, from the soul and the driving decision-making force. Okay. Descartes himself considered man as made from these two components. I have heard this name. I think he's the person who invented the Cartesian system. Rene Descartes. Oh, yeah, father of modern philosophy. Who invented Cartesian system? Cartesian plane. Rene Descartes. Exactly. Exactly. Oh, I have heard of him. Yeah, yeah, yeah. I've heard of him. Himself considered man as made from these two components, it is generally admitted that his model of animal machine was induced to him when he learned about the existence of the simple automaton, an idea later extended by Lamettrie's concept of the man machine. This may be a glimpse on the process by which an object initially built as a simple formal simulation of the given phenomenon can be a model meant to describe and explain that phenomenon. Okay. Honestly speaking, the the initial part of this book, let me just get to the index. Where's the index? Let me just get to the index. There it is. So the genealogy of artificial being from this part is definitely the boring ones because we are technically not doing anything related to modern robotics, but it's actually giving me the idea that it's actually giving me the idea that or that that perspective that how human beings went to do modern robotics. I mean, it's crazy. For someone who does not like philosophy, it's probably not going to enjoy this particular part. But I think I should say that you should definitely read this because it does give you a abstract idea or just a small idea that how humans came up with making robots. Okay, so we were on page 35. About a century after Descartes, the automata built by the Jacques-Dors family initiated a separation between the matter and the information. Not only were they were driven by the equivalent of the programs that were advanced versions of those created by the uh, I can read this word. And Heron of the Alexandria built the programs themselves, regarded in the roles, camps, and disk would be changed. Thus modifying the internal states of the automata, they became the independent of its material moving components. Changing the program open spaces of possibilities that remain limited, but nonetheless real. One of them, given automata, the musician player could play five pieces of music. The second one, the drawer, could create a four different drawings. The last one, the writer, was the most complex. It can draw 40 different characters, the text to be written and coded on dented wheels, which makes it a fully programmable automaton. By looking at these delicate and impressive technological pieces, uh, one can one can only regret the almost wait regret the almost complete disappearance of automata art since 19th century. Fortunately, a few passionate artists still maintain this practice today. Some of their most recent works, such as Francois Janot Free, I don't know, that's not English. I don't know what that is. Oh, okay, so whoa, what is that? I'm not gonna open the video to avoid any copyright, but damn, that looks crazy. Can I zoom in? No, I can't, but damn, that looks crazy. Are nothing less than jewelry pieces in movement and can be expelled. Junot's studio is located close and the Swiss town of La Croix de Fund, the first town ever planned around the activities of the watchmakers. Okay, so basically they're just talking about some they're just talking about these. So this is a watch, according to the book. This is a watch. I mean, that's crazy. That's crazy, man. So this is a musician. So this is the drawer. which could draw, you know, 40 different characters. This is the musician and this is the writer. Okay. Babbage and the computer robot scheme. The bifurcation that made the automaton and its controlling programmed two distinct identities cannot be located on a single moment at a time. As we have seen, it can be tracked back to the devices created by the early Greek engineers to the El Zaris percussive automaton, but several other steps intervened since the trajectory leading to contemporary computer programming has taken an unexpected detour through the music and textiles. Okay, all right, I get this. 75 years later, Jacquet's Doors Automata, Herney Lecotre created a musical box in which the melodies were recorded on interchangeable rolls. Barrel organs, which first appeared during the 16th century, could play melodies that were pre-recorded on the roll's disc, cards, or ribbons perforated with the holes that determined the melodies to be played. Such instruments were actually called auto automatophones. Automatophones means the phones basically which we use, I think. Let me search up for that word. As a To mimic live produced sound or automatically play music through predetermined sequence such as gear levers or pin cylinders. Okay. This principle was almost immediate transposed to create the first Jacquard loom by the Basil Bichon, the son of an organ maker. Organ maker. What is organ maker? What do you mean by organ maker? Oh, okay. So it's something related to music. And by his assistant, Jean Baptiste Falcon. Bro, what are these names? I mean, like, duh. Am I here to read names? They adapted musical boxes and mechanism for from his manufacture to create the card readers that control the patterns to be woven. It is worth noting that the Jaculium also used the cylinder developed by the Vacanson and another illustration that technology is required to implement machines with the practical uses often originated from the artistic realm where they were developed with completely different motivations. Okay, okay, I see. It means that a different field is basically motivating a different field. The pre-pirated card system lasted for more than 2 centuries. It was extensively used for programming of the first generations of computer. It played an essential role in Manhattan Project during which the first atomic bomb was created. Oh my God, what are we talking about? Oh, it's a loom. So what is a loom? What is a loom? Oh, oh, okay. So, oh, all right, okay. So it's basically a device which is used to fabricate things, fabricate clothes, not things. Establishing a odd and particular connection between the delicacy of the melody played by musical box, the pattern on the cotton fabric, and the thundering apocalypse of the nuclear explosion. It was also observing the Jacqueline that Charles Babbage had an idea to design his analytical engine, today considered the first a full computer in history. This huge machine included all the main elements of a modern computer: an input device that separate data and instructions, thanks to the punch and readers, a mechanical drive that prepare and organize the data for processing, a mill made up of the 100 gears that perform the operate the mechanical equivalent of a CPU, a memory which store in the intermediate and the final results, and an output device in the form of a printer. Oh my god. The analytical engine was never completed. Due to problems of financing and manufacturing precision, it however remains, along with the Jacquard loom, and the first example of a device that fully and completely separates the flow of the information from the material processing unit. It is also remarkable for the another reason. Ada Lovelace. Oh, Ada Lovelace. That's the first. In case if you don't know, she's the first woman programmer, I guess, mathematician. Or yeah, she famous for so first. She was world's first computer programmer. Okay. Uh, Lovelace architecture. I've heard of this. I was reading. So, Nvidia has one of its chips. I think that's third generation. What Nvidia architecture? God, tablets architecture. Okay, so Nvidia 40 series, the 4060s, 4070s, have this particular architecture. So here's basically the list of. Okay, I have a RTX 3060 Ti, so my current architecture is not that, but okay, okay, all right. The daughter of poet Brian was fascinated by mathematics. She wrote for the Babbage machine, the first known mathematical algorithm. Oh, whoa, wow, okay, the sequence of the instructions for computing Bernoulli's number. Bernoulli's number, what's that? What's that, bro? Bernoulli's number is a sequence of important rational numbers that frequently appear in the number theory, calculus, and etc. Oh, okay, so that's Bernoulli's number. B naught equals 1, 1 over 6, B30. Okay, okay. Which makes her the first programmer in the history. The clairvoyance and the insight were actually nothing less than a visionary. She Oh, that's the first analytical engine that was made by the Babbage, Charles Babbage. Yeah, foresaw the possibility for such devices to perform not only the numerical operations but also the symbolic calculations, and to use them to associate letters and signs in order to produce results that has nothing to do with the mathematics, such as a composition of the musical pieces in another loop that reconnected the machine with its musical box origins. This is probably the first known evocation of a form of artificial creativity, a characteristic which perhaps more than for many other automata testifies for the impulse to bring machines closer to human beings. Art at the time was seen as prerogative of human species, i.e., still largely preponderant preponderant today. What does that mean? Let me search for this term. A larger larger in number or more important than other people or things in a group. If this book is gonna throw such hardcore English towards me, I'm probably gonna end up searching the meaning of the words half of the time. Oh, that's not good. The question of the relation between the arts and the robotics and the automata will discuss more in the 6.2. Okay, so that's the in which I don't. This is basically the formula for Bernoulli number. So Sm as a function of n can be written as 1 over m plus 1 summation from k equals 0 to m. Okay, and this is basically the permutation, the combinator formula. This is basically m plus 1 ck bk, and okay, so can be obtained through the following generating function: x over e raised to power x minus 1 equals summation from k equals 0 to infinity till we are basically adding this number. Okay, and a Lovelace algorithm was derived from this function. Okay, I don't know what this function does, but ooh, so we have arrived at industrial revolution. Wait, let me just get to how many pages do we have left until we start the next chapter? 43. Okay, unfortunately, we are not going to start that today, but we are going to start that tomorrow. Okay, what page I was on? I guess I was on 39. Ooh, that was a good guess. So, technological progress. Uh, I need some water. What time it is? It's 8:07. I need some water. I'll be just back in a second. Okay. Let me get some water. All right. I'm back. I'm back. I'm back. Let me just side this up. Yeah. So technological progress took a new pace over the course of the last 2 centuries as the Western world underwent that we refer to as industrial revolution. The plural form is used here because at least the four revolutions that has been identified, the first major change intervened as a result of the use of the steam and the water to generate power. The second corresponds to the emergence of a mass production and the division of the labor, and the second to discovery of electricity as a power source. The third took place at the end of the 60s, which automated production and the exponential development of the computing and electronics of what can be as a digital revolution. Yeah, so currently we are in the digital revolution. It stands as a result of the merging of technologies that broke down the limits between the digital, physical, and biological spheres. Field of application of the last revolution is often referred to as Industry 4.0. Okay, the first revolution is direct implementation at the large. I'm just going to read it real fast. At the large scale of the several early contributions that were mentioned above, but it was also grounded on many works by Leonardo da Vinci. It is only in the third one that the first robotic systems were widely adopted through. It seems obvious that the second rare revolution paved the way for it. The third revolution exploited in the discoveries and breakthroughs made by several inventions, among which the Nikola Tesla is certainly not the least. It is during the third revolution that the linger of robots branched from the main trunk of the genealogy of automata. For the first time, artificial entities endowed with the degree of automata were put to work, becoming nothing less than the automated servants or slave incentive to fatigue, 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 not vulnerable to health hazards and hopefully more robust and durable than human workers. The fourth revolution will not be discussed in this book as history is still being written on the impacts of the changes that brought, but it will be referred to in the last section of this chapter. Okay, what's the last section of this chapter? Projects, ethical design, interaction. Okay. Of this chapter. Okay, so it's the end of this chapter. Okay. Uh, Last section of this chapter. Okay, so in the last section of the chapter, we're probably going to discuss that what's actually going in today's era. In 2026. Okay, the rise of the industrial robots during the 20th century required several scientific breakthroughs in the power, electric, pneumatic, hydraulic power transport, and teleoperational. Nikola Tesla was an engineer and an inventor who referred to himself as a discoverer. He solved most of the requirements and constraints needed by the third industrial revolution and stands out, but about 300 patents, as most of the brilliant inventors of his time. He is widely known for his contributions on electricity and transport and alternating current. These works had obviously a major impact on robotics, but we will focus on his contribution to the use of radio waves. In November 1898, Tesla demonstrated that a small autonomous boat could be remotely operated from the distance up to several feet. The instructions were sent by the code pulses of electromagnetic waves on the demand of his audience. He instructed the ship to turn left or right or to stop. This was the first demonstration of a remotely operated vehicle. So that's a remote controlled car. It is not a robot in a full sense of the term, but it was accordingly to his inventor, borrowing the mind of a human operator so that future advanced versions could fulfill mission together. A handful of the patents, such as the one on advanced individualized protected multi-brand wireless transmission, followed by his demonstration. Another one concerned the first and circuit, a device that combined two radio to minimize the risk of the interference. Oh my god, that's crazy. Tesla's boat would be hardly more than a toy today. Exactly. At the time, he was nothing less than a fortuner forerunner of the remotely controlled devices and system. He tried to write a list of all his potential applications. By reading it, one cannot help to find him a little bit optimistic about the consequences of the military ones. Okay. As for every new technology's big breakthroughs, the militaries were quick to foresee the uses that could make for his invention. They massively funded the research on related technology and quickly developed remotely operated equipment in the operational fields without, as could be expected, helping in any noticeable way the pacification of the conflict areas. As he foresaw at the time, the most advanced robotic research ventures and developments are still funded by the military. Oh, that's crazy. So it says that the most advanced robotics research ventures and developments are still funded by the military industry, which is still the first to develop new technologies. Oh my god. Is it true? Bro, is it true? Bro, holy shit. Is this true in 2026? Oh my god. It means if I'm working towards robotics and if I want to make robotics as my career, I could join a military. Oh my god. Holy shit. 13.4 billion. Oh, whoa. Especially dedicated to the AI and autonomous systems that provide funding for everything from unmanned aerial and sea swarms to complex multi-agent swarms. Whoa, damn, that's crazy. Okay. From mythological and large poetic origin, robotics became within a few decades a field in which sophisticated war machines were developed. Oh my god. I don't want to make a war machine, you know? Like, here's the thing, my main motivation to study robotics is basically to work with the vision technology. That's one of the most amazing thing that I have ever encountered. uh, you know, not with the core robotics itself, but in order to go there, I'm actually trying to be multidisciplinary, and in order to do that, you do need to learn basic robotic things. Okay, so while most of work done in this domain are not publicly available, some initiatives do contribute to the general advancement of this field. Nowadays, the United States Defense Advanced Research Project. Oh, this is what the the Gemini is talking about, you know? That's crazy. It's hosting several risk challenges, autonomous vehicle races, humanoid emergency response, heterogeneous robotic swarms tactics. Okay. So this is uh Unimate robotic arm developed by the General Electric facilities to in 1963. Whoa. And subterranean exploration. Some of the competitors of these challenges are funded $1 million by DARP, DARPA to push the boundaries of their research. If we go back to industrial realm, mass production in the third revolution has resulted in a lot perspective task and manufacturing process. Most of them were perfectly fit for simple, robust automation. The 60s welcomed the first industrial robotic arm, the Unimate, designed by the George's evolved, even if the early version of the digital switches, the digital encoder were commercially available at the time. None of the self part would fit his design, so every single component of the first set of the Unimates were specifically manufactured for it. It was developed by the General Motors in 1961 and was object of the first on-site study for market integration, ease use, ease of use, and safety of industrial robots. Several lessons were learned from it. Two, two of them proved essential. The first one, that a robot adolescence is likely to strike well before utter wear out. It led to conclusion that the life of industrial robot depends on the robustness, ability to hold together, as well as on the versatility, ability to involve and to use skills. Okay, so over here, the life of industrial robots. Okay, new jobs. So here in the second thing, ability to evolve and adapt to new jobs is basically what they're talking about, the intelligence, the artificial intelligence. The second one relates to the fact that complexity of a robot is so high that it becomes difficult to guarantee its reliability. Uh, Criterion that depends on the owner programming skills and on the production system into which a robot is integrated and the quality of its maintenance. It is, however, important to note that after the Unimate was used for about a decade, several owners agreed that the financial benefits of replacing human workers with it were not significant, but it was still wanted to go along with because it kept their workers away from the industrial accidents and health hazards. The Unimate feature up to six axes, one of them paramedic translation, payload of 225 kgs. Damn, that's a lot. The first one was sold at a loss, but after 6 years, the company, Unimation Inc. started to do profits. It later changed its names to Stabui. The others then joined the market, such as ASEA with the IRB series. I don't know what that is. The first commercialized IRB, the IRB 6 has 5 axis and a payload of 6 kilograms, focused on the ease of the integration of its product, whose overall mass was 112 kilos, and those integrated control electronics, including its DC actuators, were fully integrated within the enclosure. The merge and the brown, okay, become two. Okay, so they're just talking rubbish. They're just talking bullshit that how these companies are basically competing with each other. Okay, modern robotics. How many pages do I have left? I think that's the last page. Please tell me it's the last page. No, it's not. Teaching and learning robotics. Okay. Should I read this? Should I read this because I've already raised page 42, and according to our target, we were supposed to read 10 pages per day, not even 10. Initially, we started with 5 pages per day. I think that should be enough for today. Modern robotics. So, okay, let's just read this part. We're not going to read 1.6.1. Just read let's just read this. During the last decades, the industry was trying though several attempts and test sites to robotize manufacturing process. Tremendous progress on the robotic system design, kinematics, and sensing control were achieved. The corpus of the knowledge on the advanced robotics systems resulting from these breakthroughs constitute the fundamentals of the modern robotics, the field that explores the possibility of deploy reliable robotics in the unknown dynamic environments. One of the most important phenomena of the period is certainly this progressive convergence between the biological and the robotic system that can be observed since the end of the 70s, during which the old attempts of stimulating life through the former analogies gave places to new experiments that tried to reproduce the dynamic aspects of the biological process. Okay. Oh, so we have finally arrived at modern robotics. Damn, that's crazy. What's this? Let's just read about this. It's a Stanford Shakely robot. Prior right was the tortoise. Oh, that's a tortoise. That's crazy. Okay, so tomorrow we're gonna start with coping with the unknown. I think that is enough for today. It's 8:24 and it's been 48 minutes since I started recording this video. All right, so that is it. That is it for today. See you tomorrow, and I'm gonna continue with what lecture I was supposed to continue with in probability. Let me see. Let me just see. Just give me a sec. Let me check my notes. I really have a bad memory. Okay, we have to start with lecture 5 of probability. All right, see you tomorrow.